This video lecture is meant to cover the information found in Unit 1, Section 5 on dimensional analysis. Dimensional analysis involves metric conversions, and in order to get you back into the swing of things with metric conversions, let's revisit the various metric prefixes that you'll be expected to use this year in honors chemistry. If you refer to Table C in your reference tables, you will see that there is a list of selected prefixes. In this chart, you'll see 3 columns. You'll see the power of 10 that prefix refers to, the name of the prefix, and then the symbol that is used in the unit. Each prefix represents a factor of 10. Kilo means 10 to the third, which is of course equal to 1,000. Deci means 10 to the negative 1, which is really equal to 1/10. And milli means 10 to the negative 3, which is 1 over 1,000, which is really 1/1000th. What if you don't have a prefix on the unit? Let's just say you have a meter, or a second, or, as you'll start to hear a lot in this class, a mole. If you have a unit that has no prefix on it, no metric prefix on it, then the factor is 1. And of course, when the factor is 1, that's the same as saying 10 to the 0th power. Okay, so you'll need to recognize that as we work through some of these problems. And of course, 10 to the 0 fits in right here, and that's for your base unit. So that's where the magnitude of your base unit would fall between the kilo prefix and the deci prefix. So dimensional analysis is a fancy term that helps us to convert metric conversions. It's also used to convert more complicated units. It's sort of a mathematical technique that we will be using actually throughout the course of the year. Dimensional analysis is a very useful mathematic tool. You're going to possibly want to resist using it when the problems are simple because you might just intuitively understand what's going on in the conversion. But if you step back and realize that the purpose of dimensional analysis is to help you convert the unit on a measurement or to somehow manipulate the unit on a quantity, this is just a very structured way to show your work in chemistry problems. Keeping in mind that the result of dimensional analysis is there's no change in the absolute quantity of the measurement. You are just expressing that measured value with a different unit. So to use dimensional analysis, the first thing you'll want to get comfortable with is creating conversion factors or fractions from this table C. So let's just say you have the unit of kilometers that you want to convert into centimeters. So what you will do is you look up on table C, kilometer is a factor of 10 to the third. So I'm just going to jot that down. Centi, in the centimeters, is a factor of 10 to the negative 2. So what you need to do is recognize that when you're looking at these exponents, on a number line, the difference between those two factors is what you are going to use in your conversion fraction. So what you'll recognize is from 10 to the 3 to 10 to the negative 2 is a total difference of 10 to the 5th. Okay, so when you're expressing the differences, these are going to be positive exponents. All right, so what do we do with that? Well, what this means is that 1 kilometer, and I'm going to put a 1 in front of the kilometer because it's the larger of the two units. So 1 kilometer has 10 to the 5th centimeters, which of course is 100,000 centimeters. All right. So what you are going to do is use this equality. Basically, this is what we're going to refer to as the equality. And your possible fractions or conversion factors that you will use will either be 1 kilometer over 100,000 centimeters, or you will use 100,000 centimeters over 1 kilometer. Depending on the conversion, the direction of your conversion, you may need to use either one of these fractions. Let's try another one. Centimeter to micrometer or micrometer, depending on how fancy you want to sound. Referring to table C, centi is 10 to the minus 2. A micro is 10 to the negative 6. So here we can see that the difference between these two factors is 10 to the 4th. Remember, your differences are always going to be a positive exponent. So what this means is we're going to say that 1 centimeter, because centi is the larger of these two units, 1 centimeter is equal to 10 to the 4th micrometers. And of course, that is equal to 10,000 micrometers. So there is your equality, and your fractions can either be 1 centimeter over 10,000 micrometers or 10,000 micrometers over 1 centimeter, depending on what you'll need. So the idea is that these fractions are flippable because they are an equality. 1 centimeter equal to 10,000 micrometers, because the numerator is equal to the denominator. Your whole fraction is equal to the value of 1, and that is the key to these conversion fractions. Let's do another one here. Nanometers to millimeters. Nanometers is 10 to the negative 9th. Milli is 10 to the negative 3. So the difference is 10 to the 6th. Milli is the larger of the two units, so 1 millimeter is equal to 10 to the 6th nanometers. Okay, so then your fractions can either be 1 millimeter over 1 million nanometers or 1 million nanometers. Oh, how about a few more zeros there? Get a little ahead of myself. 1 million nanometers over 1 millimeter. All right, let's put these to the test. Couple problems here. Now we're going to actually convert a measured value, in this case 45.3 grams, we're going to convert it to nanograms. So when you're given a conversion problem, the first thing you'll do is set up the problem so that you are starting to the left side of your page with the unit you are starting with, the value you're starting with, 45.3 grams. The next thing you will do is set up your conversion fraction that you will multiply by. Okay, so we're going to multiply by a fraction, and in this fraction I'm going to put the unit of grams in the denominator so that it will cancel with the grams that we are starting with. And the unit that I'm going to, nanograms, is going to go in the numerator, so that way we will be left with the desired unit. Okay? Now we know that grams is the larger unit than a nanogram, so I'm going to put a 1 next to the grams. So the question is, how many nanograms are there in 1 gram? Well, if we use our technique, grams without any prefix has a factor of 10 to the 0, and nanograms is, nano is 10 to the negative 9th, so the difference between those is 10 to the positive 9th. So what we have here is a billion nanograms in 1 gram. All right, so now you have your conversion fraction set up. If we take a look here, we will see that grams will cancel. And what you are left with, well, now you have to put this into your calculator, 45.3 times 1 billion, and you will get a very large number. What is that, 45 trillion, 300 billion? Okay, so this is a great case, a great chance for us to put this number into scientific notation. Your calculator can force it into scientific notation if you choose. To do that, you would need to use the green second function, and then you would hit the button that's labeled 5 because SCI is above it, and that will put it into scientific notation for you. Or if you're clever enough, you can do this on your own without a calculator because it's pretty simple. So 4.53 puts the coefficient into the proper format. And so this is going to be 10 to the 10th nanograms. So either one of those answers is correct. 4.53 times 10 to the 10th nanograms is a little bit classier to use. All right, let's take a look at another example. 32.1 centimeters, 2 kilometers. We're going to start with the number that is given to us, 32.1 centimeters. We're going to set up our fraction of centimeters on the bottom to cancel, kilometers on the top. The larger of these two units, of these two prefixes, is the kilometer. So 1 kilometer is going to be equal to some number of centimeters. To figure out that number, we go to the chart, table C. Centi is 10 to the negative 2. Kilo is 10 to the positive 3. The difference between those is 10 to the 5th. So that would be 1 kilometer is 100,000 centimeters. And if we take a look here, centimeters will cancel. And when we multiply this out in our calculator, 32.1 divided by 100,000, we're going to get the number 0.000321 kilometers. Let's make that nicer looking and put that into scientific notation. 3.21 times 10 to the negative 4 kilometers. All right. Problem 3, converting 0.982 kiloseconds to milliseconds. Again, start with the number you are being asked to convert, 0.982 ksec. Set up your conversion fraction. In this fraction, the denominator unit goes first to cancel out the kiloseconds. Milliseconds goes in the numerator. The larger of these two prefixes is the kilosecond, so we're going to put a 1 next to that number. To figure out what 1 kilosecond is equal to in milliseconds, we need the chart. Kilo is 10 to the 3rd, milli is 10 to the negative 3rd. The difference between those two factors is 10 to the 6th. Okay, so 10 to the 6th is going to be 1 million. In your calculator, the kiloseconds will cancel out. 0.982 times 1 million gives us 982,000 milliseconds, or if we want to put into scientific notation, 9.82 times 10 to the 5th milliseconds. All right, one more problem and then we'll be done. 1,200 microliters to centiliters. Starting out with the measurement that we are given, 1,200 microliters. Set up your conversion fraction. Microliters in the denominator, centiliters in the numerator. The larger of these two prefixes is the centiliter, so I'll put a 1 there. Micro is 10 to the negative 6. Centi is 10 to the negative 2. The difference between those two factors is 10 to the 4th. 10 to the 4th is, of course, 10,000. So 1 centiliter has 10,000 microliters. Canceling out the microliters, we now have the math problem of 1,200 divided by 10,000, and we get 0.12 centiliters. And that's how you use dimensional analysis to do metric conversions. See you in the classroom.